So in this video, I'm going to go over some examples of problems that are similar to those that are in your Unit 3 TGA. So here it says the table represents the annual sales of a shoe company for the last 5 years since the grand opening. Using regressions and Desmos, write a linear regression to model this data set. So remember, whenever you have a table that's written like this, even though it's horizontal, you're going to turn it into a vertical table when you go to Desmos. So for me, sometimes it's helpful to just go ahead and write this as a vertical table before I type it in Desmos because it helps me keep everything in order. So you can see here the first row is X, second row is Y, and I'm just kind of rewriting what I have in this table right here. I'm just doing this as reference to myself, so you don't have to do this step if you don't want to, but for me, it just helps keep everything organized. So now that I have my table written out, I'm just going to go here and click the plus sign and then choose table. And then I'm going to go ahead and type in all these values. So now that I have all these values typed in, you can see I have a linear pattern in my data points. I'm going to go ahead and click add regression, and then linear regression is the default. So you can see now I have my equation, which is y equals 0.35x plus 1.63. Okay, and that's all you need to do on question one is write the regression line. So now let's look at an example similar to number two. So here we have a scatter plot that's given to us, and it says that a student chose to model this data with a linear function y equals 0.52x plus 15.34. So is this an appropriate model for this data? Well, you can see that if I draw a line, it's really not going to go through these data points and give me a good idea of the pattern, right? So if I look through these data points and I kind of think about like connecting the dots, you can see it follows more of a parabolic pattern, right? It looks like a parabola, so a quadratic is going to be a better fit. Okay, so I'm going to choose to do a quadratic. And then what I'm going to need to do is I'm going to need to use Desmos to go ahead and create a quadratic equation to model this data. So once again, I'm going to do add item and then table. And now each of these points I'm going to type into my table in Desmos. Okay, so I'm just going to start at the left and then just go around my parabola and type in my data points. All my data typed in, I'm going to click add regression. And from the drop down menu, I'm going to choose quadratic. So you can see here, it gives me the equation of a quadratic that models this data. I have y equals negative 0.2x squared plus 4x plus 3. So now let's look at an example like number three. So here it represents the growth of a bacterial colony each day in the scatter plot. What model would be used to best represent this data? And let's write an equation that best fits this data and use it to predict the number of bacteria in the colony after 5 days. So if we look at this trend here, you can see it starts off slow and then it goes up pretty quickly, right? Whenever we have this kind of pattern, an exponential function is going to be best to model this data set. So what I'm going to do now is I'm going to go ahead and go to Desmos, and I'm going to click the plus sign and then choose table. And then I'm going to go ahead and type in these values in my table. And then what I'm going to do from the drop-down menu, I'm going to choose add regression and then select the exponential regression. And you can see it gives me the equation y equals 1 times 2.4 to the x. So that's going to be the equation. And then what I'm going to do is have Desmos export this equation. And then I'm going to go ahead and change that y equals to f of x. Right. So I'm going to redefine this as the function f of x. And then in the next row, I'm going to say, well, predict the value at 5 days. So I'm going to say, well, can you please calculate f of 5? Okay, so you can see here it gives me 79.63 if I round it. And so there's going to be 79.63 bacteria in this colony after 5 days.